All right, so for the quiz 6 review, this is all based on radicals. Remember, we were in section 6.2 simplifying radicals, and then we ended up adding and subtracting them, multiplying them, and dividing them, right? That's all we kind of did. So question number 1 is just basically an addition, right? One of the main rules that you guys have to remember is that when it comes to adding and subtracting radicals, they have to have the same radicand, meaning the number in the middle has to be identical. Or not the middle, the number inside the radical has to be identical. So this has a radical 3 and a radical 3 on both. So that means you can just add 6 plus 2. So for us, this would just be 8 radical 3. And that's it. That's all you need. You don't have to do anything special. It's just notice that they have the same radicand. If they do, add the coefficients, which are the numbers in front of the radical, and that's it. Okay? So easy. And there will be questions like that on your quiz, so it's not like everything's going to be super difficult. Okay? But there will also be questions like number 2. So these are not supposed to be like super difficult either, but they are assuming that you guys can break these problems down. Notice there is no square root to 20, there is no square root to 45. So you're going to have to break them apart. So I would probably start off by saying, okay, what two numbers give me a 20 when I multiply them, but hopefully one of those two numbers has a square root attached to it. So what two numbers can I use for 20? 5 times 4, all right, good, 5 times 4. And then what two numbers can I use for 45? 9 times 5, okay, perfect. So the 4 has a square root, the 9 has a square root, okay? So this will come out and become times 2, this will come out and become a times 3. I know I wrote that kind of small, but I did that on purpose because I don't want it to distract from the problem. So 3 times 2 is 6 square root of 5 minus 4 times 3 is 12 square root of 5. Now you notice how they both have a square root of 5? That means that I can combine them together. So 6 minus 12, that's a negative 6 square root of 5. And there's my answer. And yes, there will be questions like this on your quiz. Remember, all these reviews that I do, I basically just get questions from your quiz and just change some numbers, and that's about it. So you'll see questions like this. You're going to see questions like number 3, where there's 3 things listed in order. And you're going to have to try to see what you can do to simplify and solve. Any questions so far? All right, so let's check out number 3. You'll notice I gave us a little bit more room than normal because sometimes these can get a little longer depending on what numbers you choose. So notice none of them have the same radicand, right? There's a 27, a 10, and a 12. Like, they don't match, so I can't just combine. So I'm going to try to break down. So for 27, think of two numbers that multiply to 27. That have a square root, one of them at least. 9 and 3, thank you. 9 times 3. 2. Now, think of two numbers that multiply to 10, one of which should have a square root. Do we have it? Do we have any? No, right? Because 10 is 1 and 10. That doesn't have square roots. And 2 and 5, none of those have square roots. So that means this just stays like that. Okay, nothing happens. All right? What about square root of 12? Any two numbers that I can multiply for that? 4 and 3, thank you. All right, so 4 has a square root, 9 has a square root. I'm just going to kind of highlight them for us. Remember, when the 9 goes out, it's going to multiply by 3 because that's the square root of 9. And when the 4 goes out, it's going to multiply by 2 because that's the square root of 4. So 4 times 3, that's 12 square root of 3 minus 2 square root of 10 plus 4 square root of 3. Am I done? Or is there anything else I can combine? Yeah, the radicals with the radicand of 3, right? Those can be combined together, these two right here. Okay? So these are the ones that I want to combine. So 12 plus 4 is 16. Square root of 3 minus 2, square root of 10. And that's it. There's my answer. Like I said, you will get problems where they're going to give you 3 radicals and you're going to have to break them down and see how much you can combine. Maybe it becomes just 1 term, maybe 2, maybe you can't do anything and it stays as 3. You know, it just depends on the problem. Any questions on this one? All right, so question 4, there will be cubed roots. Okay? So, cubed roots. Again, you guys are able to use your notes. Make sure you guys have that list of square roots and cube roots and stuff to help you out, because it's going to become really important for questions like this. There is no cubed root to 54, but I can break it down into 2 numbers, one of which does have a cubed root. Okay, so in case you don't know, let's think of factors for 54. There's 1 times 54, but usually that one we don't want to use because of the 1. 2 times 27. Do any one of those numbers have cubed roots? The 27. Yeah, the 27 does. The cubed root of 27 is 3. So this is a good option. Okay, that's a good option. So, 2 times 27 plus 3 cubed root of 2. 2 only has 1 and 2 as options, and none of those are going to have cube roots, so we're kind of done on that side. So, the cubed root of 27 will come out and multiply by 3. So the front is going to be 3 cubed root of 2 plus 3 cubed root of 2. Since those have the same radical and radicand, right? Cubed root of 3, cubed root of 3, I can combine them. This will become a 6. I'm sorry, cubed root of 2. I'm saying 3. Cubed root of 2. 6 cubed root of 2. And that's it. I think I've been telling you guys this since yesterday. I personally don't think that the work that they make you do is extensively difficult. Like, it's not a lot of steps. It's just a lot of tiny steps, right? So you got to break something down and think about, okay, what has a cubed root or what has a square root for this or that. So it's just a lot of little tiny steps that you need to do right. But it's not like an extensive amount of time that you're going to be working on these things. It's just be careful, use the right numbers, and you should be able to get the right answers. All right, so now after we're done with the first 4, remember we have 9 total, right? Let's move on to some of these that have letters. Now, remember the rule for letters is you have to, first of all, figure out what is the index on my radical, and then you got to make sure that all the variables have the same power as the index on the radical, right? So if it's a cubed root, you want a bunch of cubes on your variables, right? As many cubes as possible. If it's a square root, you want squares on everything. Okay? So when you multiply, remember, you just go straight across, right? 2 times, let me write this down here. Square root of 2 times 6 is 12, and that's x to the 4th. Now I got to break down 12. Right? What 2 numbers can I use to break down 12? One of which should have a square root. Okay, 4 and 3. And then my index on this problem is a what? A 2. There's a 2 right there, okay? We just don't see it. That means that my powers all have to be squares. So x squared, that's x to the 4th. If you guys remember when we did this, I would highlight the information that was coming out, and I would draw arrows, right? So when that 4 comes out, it's a times 2. That's an x. That's another x. So this comes out to 4x squared, square root of what? 3, right? So the x squared is because x times x, right, on the outside. So that would be my answer for number 5. Go ahead.
How did you get the x, 4x?
2x, oh, you're right. Yeah, were you going to check me on that too? All right, good. Thank you for that. Let me write some initials here. All right, so yeah, 2x squared radical 3. So yeah, my mistake when I took out the 4, I left it as a 4. It should have been a 2. I even wrote it there as a times 2 and still ignored it, right? So yeah, 2x squared radical 3 would be your right answer. Any questions on 5? All right, so let's look at 6. 6 is not a multiplication problem, but I am going to have to break it down little by little. Okay, so I'm just trying to figure out why this is having some issues. Give me a second. All right, so for number 6, we just got to break stuff down. Now notice, at first, square root of 16 is not a big deal, right? What's the square root of 16? 4. So this actually gets to go out immediately, but let me break down the variables. So before I kind of start writing things out, I'm just going to leave that as 16. My index is a 2 because it's a square root. So that means I got to break down x cubed and y to the 4th. X squared x, y squared y squared. Okay? And now let me highlight what's going out. The 16 is going out. This x, this y, and that y right there. Because the powers match the index. So, just drawing some arrows here. This is going to be a times 4. That'll be an x, a y, and a y. So, I get 4x y squared. That's what's coming outside. And then inside, the only thing left is an x. So there's my answer. 4xy squared, square root of x. So no multiplication here, but I mean, the thing you guys got to realize is even though number 6 didn't have multiplication, number 6 could have been a result of 2 things multiplying, right? And then from there you have to work it out. So it doesn't mean that you can't just get that type of answer from multiplying. You could. All right? So let's look at 7, and then after that we're going to do some division ones that we just kind of went over yesterday. And that's it. So we're getting up to question 9 eventually. So number 7, a cubed root of 24, x to the 4th, y to the 6th. My index for this problem is a 3. That means that all of my variables need to have cubes. Okay? 24 does not have a cubed root. Okay? So I am going to have to break that down into 2 other numbers. What 2 numbers can I use for 24? One of which is a cubed root. 8 and 3. Perfect. So here we go. Cubed root 8 times 3, x to the 3rd x, y to the 3rd, y to the 3rd. So I've set myself up so that everything possible can come out. So the 8 will become 8 times 2. This x will come out. This y will come out. This y will come out. So I have a 2xy squared cubed root of what? 3x, right? There's still an x there. Kind of hidden there, but... So there you go. That's number 7. Are we good so far, guys? Anybody need me to go back to something, discuss something from before? All right, so question 8 and 9 are things we did yesterday. All right. So, I told you guys yesterday that the first thing you want to do is ask yourself, can you simplify this by maybe combining the two radicals into one big radical? Right? Radical 3, and you don't have to write this down, I'm just going to show you really quick. There is nothing I can do with that. It doesn't simplify into anything, or I can't make the numbers smaller, nothing. There's no purpose for that. So, I am not going to combine the radical 3 over radical 2 into one big radical, okay? And that's usually the way I decide. I ask myself, let me look at this. Will I get something from it? So, the one thing I can do, and let me just rewrite this problem here real quick. I can reduce this. This will be a 1. This will be a 3. So that'll become radical 3 over 3 radical 2. I can reduce the numbers in front. What's the problem here with this? What's wrong with it? Yeah, there's a radical in the denominator. So how do I get rid of the radical 2? What's the word? Starts with an R. Rationalize, right? And I don't have to rationalize by 3 radical 2, just by radical 2. So on top, radical 3 times radical 2 is radical 6. On the bottom, I get 3 radical 4. What's the square root of 4? 2. So, I get radical 6 over 3 times 2, which is radical 6 over 6. Can I cancel out those 6's? What do you guys think? No, right? In order for me to cancel them out, either both of them shouldn't have a square root, or both of them should have a square root. But one does, one doesn't, so you can't do it. Okay? So there's your answer for that one. And the last problem you guys have to review is a problem like number 9. There are no problems like, remember the problem I gave you guys yesterday in the homework that I did for you, which had a binomial on top, and you had to do like foiling like crazy, right? There's nothing like that on your quiz. Thank you. So there's nothing like that on your quiz. It all has just one term on top, okay? So don't worry. Okay, so what we talked about with these types of problems is obviously you can have a square root in the denominator, but since this is a binomial, in order to get rid of it, we're going to have to multiply by the what? It's called the what? Starts with the letter C. Closed, C-O-N is good. Not stint, but starts with the J after. And conjugate, right? Conjugate. So the conjugate means take the same thing, just change the middle sign, right? So 3 plus radical 2, 3 plus radical 2. So, on top, you're going to have to distribute, okay? 2 times 3, 2 times radical 2. So that's 6 plus 2 radical 2 over, and then the bottom, we're going to have to do a distribution. So here we go. 3 times 3, 3 times radical 2. So let me write that down. So that's 9. 3 times radical 2 is 3 radical 2. And then I have to do the other term. So negative radical 2 times 3, negative radical 2 times radical 2. So a negative radical 2 times 3 is minus 3 radical 2. And negative radical 2 times radical 2 is negative radical 4. what happens to the terms in the middle right here? Yeah, they always cancel. Okay, if you do it right, those should cancel out. All right, so we have 6 plus 2 radical 2 over 9 minus, well, radical 4 is 2. So that's going to be a 7. So your answer is 6 plus 2 radical 2 over 7. And that's going to be your solution. Okay? So, when you guys are doing this, practice at home. If you can, just kind of go home, get a piece of paper, write out the problems in black, try doing them, check your answers, right? If you do well, then that means you don't really need to study that much. You got it down. All right? We do have a good amount of time before the bell rings, so if you have homework to make up, go ahead and do that.